Hi everyone. After talking about the underlying reasons for how molecules combine as structural diagrams or as Lewis diagrams for molecules, after talking about the octet and the duet, it's time to see some examples. I have four examples here: H2O, water; NH3, ammonia; CBr4, which has this name, tetrabromomethane; and C2H6, ethane. I've started things off by putting the individual Lewis diagrams for all the atoms. H2O, two hydrogens, and an oxygen. As we work through this process, we're going to notice that all of the atoms are going to end up with an octet of electrons. There's going to be 8 electrons around all of the atoms, with the exception of hydrogen, which is only going to have 2, a duet. It's almost like fitting puzzle pieces together, and as we gain more experience, as our comfort level goes up, we'll just be able to go faster and faster. Here, look at this. The oxygen has 2 bonding electrons, and the hydrogens each have 1 bonding electron. The oxygen is going to form 2 bonds, and there's 2 hydrogens there, so they're going to fit together. I've done them in 2 different colors to hopefully highlight the difference between which electrons go with which atom. So I'm just going to slip this hydrogen in there. The hydrogen with its 1 dot, then the oxygen, and the other hydrogen on the other side. When we look at this picture that we've drawn, we see that there's 8 electrons around the oxygen. The original 6 red ones that were there, but now the 2 black ones, 1 from each hydrogen, are there. There's a total of 8 dots around that oxygen. It has an octet. Next to each hydrogen, yes, there's a red dot and a black dot, but that's 2. Each hydrogen has a duet. The places where we have 2 different colors represents sharing of electrons. In this spot right here, we have a black dot and a red dot. The oxygen and the hydrogen are sharing right there. The same on the other side. To prepare the final version of the Lewis diagram, any place that they're sharing gets replaced with a dash. So we have the hydrogen. There's where the sharing was, it becomes a dash. I'm going to keep the oxygen red for a moment. It has these 2 lone pairs. And then the other hydrogen. As we can still count the electrons now, only the dash counts as 2 because it represents a pair of electrons, the covalent bond. The hydrogen, the only thing that's touching the hydrogen is the dash. 2 electrons, the hydrogen has a duet. If I look at the oxygen in the middle, I can actually see 4 dots. There are those 2 lone pairs that I can explicitly see, which is 4 electrons. But this dash is 2 electrons, and that other dash is 2. So in total, we can still see the octet around this oxygen atom here in the water molecule. And the hydrogen on the other side, the same as this one, it also has a duet. We have satisfied the octet rule and the hydrogens have a duet. We're still showing the lone pairs. This is a Lewis diagram for a water molecule. To do a structural diagram, we're going to do the exact same thing. The final answer is the same, with the exception of we're going to leave off the lone pairs. So I'm going to switch the oxygen to black for consistency. We have the hydrogen. This is the structural diagram. Notice they're the same. I've changed the color for the oxygen to make them stand out. But here in the Lewis diagram, we have the lone pairs. In the structural diagram, we do not. We satisfied that table. The oxygen does have 2 bonds because oxygen has 2 bonding electrons. It has these 2 bonds touching it, and the hydrogens have 1 bond. Moving on to ammonia, it's very much the same process, only we have more parts to deal with. Here's nitrogen. It has 3 bonding electrons. And there's 3 hydrogens with 1 bonding electron each. So they all fit together like puzzle pieces. I'm going to go a little bit faster than I did for the water. The nitrogen. The same, and I'm going to just fit in the 3 hydrogens around. When I look closely now, I can see that the nitrogen has an octet. It has its original 5 red dots, and now it picked up these 3 black ones. There's 8 dots, an octet around the nitrogen. The 3 hydrogens each have 2 dots touching them, a duet. The places where they're sharing electrons, I'm going to now replace with a dash. And we have the Lewis diagram of the ammonia atom. I can still tell that the hydrogens all have a duet. They have this 1 dash. The nitrogen, there's the 2 electrons that I can see. Remember, a bond represents 2 electrons, so 2, 4, 6, 8. The octet rule for the nitrogen also satisfied. I'm going to do the same picture, but leave off the lone pair for the structural diagram. The same picture, but leave off the lone pair. Moving on, CBr4 has a name that we're not responsible for. It's tetrabromomethane. We don't care. It's the same idea. Now up another notch. We have carbon with 4 bonding electrons. It's going to have 4 bonds. And these bromines, yes, they have a lot of valence electrons. Each bromine has 7 valence electrons, but they still only have the 1 bonding electron. Wait a second. Carbon has 4 bonding electrons. Bromine each has 1, and there's 4 of them. It fits together like a puzzle. I'm going to skip to the end. The carbon's still in the middle. We're going to have the 4 bromines each attached to the carbon. I can double check my work to see if the octet rule is satisfied. Here's the carbon. It has these 4 bonds touching it, and each bond is 2 electrons, 2, 4, 6, 8. The carbon has an octet. The bromine, they each have these 3 lone pairs, 2, 4, 6 electrons, and the bond counts as 2 as well, 2, 4, 6, 8 electrons around each of the bromines. When I'm doing the Lewis diagram, I can't forget to include the lone pairs. This is Lewis. When I do the structural diagram, I might actually prefer the structural diagram because I don't have to worry about the lone pairs. It's the same thing, no lone pairs. Looks something like that. Finally, a really big one, C2H6, ethane. A good rule of thumb as we work throughout the whole unit is, chances are, if we have more than 1 carbon, for sure the carbons are attached to each other. I'm going to go fairly quickly this time again. 2 carbons and 6 hydrogens. When I'm analyzing my response to see if I'm right, I'm still looking for this idea of the octet and the duet, But if there's a larger number of atoms, I also need to double check that I used the correct number of atoms. C2, yes, I have 2 carbons. H6, oh yes, I have 6 hydrogens. That's my first double check. The second double check is, do I have an octet for the non-hydrogens? There's these 2 carbons. They each have 4 bonds. 1, 2, 3 black ones and the red one in the middle. That's 4 bonds for the carbon, 2 electrons each. The same with the other carbon. And each hydrogen has 1 bond touching it. Each hydrogen has a duet. The carbons each have an octet. I'm correct. Carbon and hydrogen do not have lone pairs. So because there are no lone pairs here, that's okay. I still have a correct Lewis diagram. However, this also shows the possibility that this is also how the structural diagram would look. Because there are no lone pairs to show in the Lewis diagram, I don't have to leave anything off, and I end up with the exact same diagram for a Lewis or structural. And there's lots of other situations where that will be the case. It's not always going to be different. When we have a molecule to draw, we have to be conscious of, is the question actually asking us for the structural diagram or the Lewis diagram? Yeah, they're very similar, but they are each distinct. Sometimes students will end up drawing a structural diagram when we're actually asked for a Lewis. That's one thing to be conscious of. If we take our time and pay attention to the octet and the duet, that's how we can double check our work to confirm that we actually have the correct structure. If there's a way that you yourself find so that you can go faster than this, that is fantastic. Do what you need to do to arrive at the answer. These are a few very common kinds of molecules, and as we proceed through the unit, there's absolutely some patterns that we can recognize. My tip for right now is, if there's more than 1 carbon, chances are excellent that they're going to be attached to each other. And I hope that helps.